Good morning. We are going to explore the derivative today, and we're going to do it two different ways. But we're going to use the formal definitions of the derivative. We're going to go way back to the beginning, and I think this will be kind of fun for you. Maybe not, but I think kind of fun because now you have all this knowledge about calculus. Now to go back to the beginning and look at the definitions again. Will be helpful, I think. So remember, the derivative is what? You guys know this. Starts with an S, ends with a lope. Yeah, you know, I know. Definition of the derivative is the slope of the tangent line. So let's just keep that in mind. Let's put that in pink because it's so important, okay? So the derivative is the slope of the tangent line. Okay. That's the very basis of calculus, right? The derivative is the slope. So if we talk about the limit derivative or the formal definition of the derivative, this is what we're talking about. So the limit derivative. And I'm going to do both limits if I can fit it on the video. If not, you'll get another video, right? Okay, so here we go. We've got some function. And let's make it a nice easy one, right? We're going to just call that f of x, some function here. And yeah, it keeps going. Let's see. Looks like a parabola, right? Okay. And we're just going to arbitrarily call this point x. So if this distance is x, then this distance here, the y value is, yeah, f of x, right? That's what we called it, f of x. So this point here is x comma f of x. Okay, just a point, any point on the graph it represents, all right? Now we're going to say, okay, I'm going to pick some point away from it, and we're going to call this distance away h. So this distance here from x is h. And so that makes this point, yeah, x plus h. You got it. It was easy, right? Okay, so then we got another point on this graph. And now this is x plus h. And then, obviously, then the y value is going to be f of x plus h, right? F of x plus h. Okay, oops. F of x plus h. Okay, 2 points on the graph. Can we find the slope in between? And you guys go, well, duh, of course we can. We've been doing that since Algebra 1, right? So our slope of this average rate of change is, excuse me, slope of the secant, of that secant line, right? Slope of secant is f of x plus h minus, so the y difference in the y values, right? We're just doing our slope triangle here, right? And minus f of x. So I just did this y value minus this y value. And then we're going to do the same thing over, right? It's delta y over delta x, right? X plus h minus x. And you can see something happens here. These x minus x on the bottom, yeah, it goes away. Now, we don't want the slope of the secant line. What we want to do is we want to bring this h value, and we want to make this h smaller and smaller and smaller and smaller so that we get a tangent slope, right? For the derivative, we don't want a secant slope. We want to bring this as close as possible to f of x, right? Or to x, I should say. So this h is going to get smaller and smaller and smaller and smaller. So we are going to take the limit. Yes, so slope of the tangent is we're going to force this h to go this direction only. So h is going to go to 0. Okay, so that means we take the limit as h goes to 0 of f of x plus h minus f of x all over h. That's the definition of the derivative, right? So instead of this slope, we're bringing these points together, so we get this tangent slope, and this equals f prime of x, or the derivative. Okay, so that's one definition. You need to know this, okay? The other definition that we also use quite a bit is the, I'll call it the limit derivative at a point. So it's the same or very similar concept, but now we're finding the derivative at a certain point, not just in general x. So let me draw the picture again. And now we're going to call this point A instead of any point x. So now A is our specific point. Maybe I should put that, I'm going to put that in at point x equals A. Okay, so now we've got a point. This is still f of x, right? And we've got this point here, a comma f of a. Okay. And now we pick some arbitrary point over here, which is x. Oops, I was doing that in pink. X, and then that makes this f of x. And we're going to do the exact same thing. Because the derivative is the slope, we're going to find the slope between these 2 points. So we take the y value, so the slope of the secant again, delta y over delta x, right? It's the same process every time. So f of x minus f of a all over x minus a, right? We just did that slope triangle. All right, now again, similar to up here, we want to close this gap. We want x to become as close to a as possible. So we're going to have x approach a. Yep, x goes to a. So now our slope of our tangent is the limit as x approaches a of the slope of the secant. So f of x minus f of a all over x minus a. And this is the derivative because we're approaching a. So this is the slope of the secant. As x goes to a, we're finding the slope right here. And that's at this point a. So this is f prime at a. Cool, right?